Hey everyone, I welcome you all to this Devops full course by Simply Learn. In this complete course, we will learn everything that we need to know to excel in DevOps. We have Matthews, Chidanand, and Anuj to guide us through this journey. We shall begin with having a short animated video. We shall dive deeper and understand what it is all about. We shall see what relevance in the present scenario. We shall learn different tools in our learning journey. The tools that we shall see are Git, Gradle, Maven, Selenium, Docker, Chef, Ansible, Puppet, Negios, and Jenkins. After we have a fair amount of knowledge regarding DevOps and DevOps tools, we will look at the interview questions that will increase our chances to crack any DevOps interview. So before we begin, make sure you have subscribed to our YouTube channel and don't forget to click on the bell icon so you never miss an update from Simply Learn. Without any further ado, let's begin with introduction.
Meet Tim. Tim builds a robot in his lab, a climate-controlled and pollution-free environment. Once he's done, he drops off at his project partner. Mia takes it out to her backyard to ensure that the robot meets the requirements. But here is where the problem arises. The change in the environment causes the robot to malfunction. Mia is now really annoyed and she has a lot to correct. And it seems to her as though Tim didn't really do much. This wall between them leaves the poor robot to bite the dust. Well, what if we broke this wall? Tim and Mia now work together in a common space. Tim develops each block of functionality of the robot, which is then immediately checked by Mia. Both are now working simultaneously instead of waiting on the other to finish their task. As and when a feature is ready for use, they are put together to build the final product. They develop a common mindset and share ideas. To further speed up the process, they use several tools which can automate every stage. This means that the robot is now ready sooner, with less iterations and manual work. From an organization perspective, Tim would be the developer, while Mia the operations. Their union is the core of the DevOps approach. DevOps has several stages and set of tools to automate each of these stages. Let's have a look at these. Tim first puts down a plan. In terms of a software, this could mean deciding on the module and the items to use. Once he has the plan, he now codes the plan. With tools such as Git, Tim has a repository for storing all the codes and their different versions. This is called version control. Next, this code is fetched and made executable. This is the build stage. Tools such as Gradle and Maven will sort this out. Now before deployment, the product is tested to catch any bugs. The most popular tool automating testing is Selenium. Once the products are tested, Mia must deploy it. The deployed product is then continuously configured to the desired state. Ansible, Puppet and Docker are some of the most common tools used that automate these stages. Now, every product is continuously monitored in its working environment. Negios is one such tool that automates this phase, and the feedback is fed back to the planning stage. And finally, we have the core of the DevOps lifecycle, the integration stage. Tools such as Jenkins is responsible for sending the code for build and test. If the code passes the tests, it's further sent for deployment. This is called continuous integration. Let's now have a look at an organization that has adopted the DevOps approach. Which of the below sequence of steps would they follow to develop a software? Leave your answers in the comment section. Keep an eye out for the right answer on the comment section or our YouTube community. Giants such as Amazon, Netflix, Target, Etsy and Walmart have all adopted DevOps and seen a considerable increase in delivery and quality. In 2014, an hour of downtime for Netflix would cost it $200,000. It became absolutely crucial that Netflix prepared themselves for any sort of failure. And so, they took to the DevOps approach and implemented it in the most unique way. They developed a tool called the Simian Army. This tool created failures and automatically deployed them in an environment that did not affect the users. The team would troubleshoot these failures, and this gave them enough experience to deal with any degree of collapse. With everything being automated and happening simultaneously, organizations can now deliver at a much faster pace. So, considering the benefits of DevOps and its divergence from the traditional methods, would DevOps be the future?
We're going to go through what we need to be able to do to go to DevOps, what the arguments are and why you need to do DevOps. And then we'll actually go through all the individual tools you need to be able to successfully implement DevOps within your organization. In addition to that, we're also going to take time and go through each of those tools so you get a good understanding of a step-by-step instructions on how to do basic setup of each of those tools. So let's get started. So what was DevOps before? So what was the process that we took for doing delivery before DevOps? Well, it was a model called waterfall, and waterfall was a very traditional approach to actually building out solutions. And the reason why it's called waterfall is that you break out all the individual requirements and individual sections of a project, and they cascade off each other. So if we look at the breakdown, we have requirements design, we have implementation, we have verification, we have maintenance, you'll have user acceptance testing. This is all based on the software development lifecycle model, or SDLC, and it's been around for quite some time and is still used by a lot of companies today. The challenge you had with the waterfall model is that it really is a very long, drawn out model for actually building and delivering solutions. So it took a very long time to actually write code and then deploy the code. It was very difficult to actually identify problems within the code and provide feedback to the development team on what to fix. And this really was a very time consuming. We're talking about months, sometimes years, for projects to be actually go through a waterfall model process. So along came a new method of being able to do delivery, and it's called Agile. And the Agile approach is a way of being able to take the actual work that's done in a waterfall model and compress it down into small iterations. And what we would do is a fundamental change is that you would actually take teams that were disparate and as part of the individual cascades within a waterfall project, and you actually bring them together. So you have your requirements team person, design, developer, and release management team all together in one group working on an iteration. The great thing about Agile is that you took a process that was weeks or months or even years in length, as it was with Waterfall, and you reduce it down to 2 or 4 week sprints, depending on the cadence for your team. Typically, you have a 2-week sprint, and then the goal is that at the end of each sprint, or sometimes every other sprint, you would do a software release, and so that customers were getting the software much faster. The problem that we still ran into, though, with Agile is fundamentally similar to what we were having with Waterfall. You have your DevOps person working on code on their system, and it'd be working great on their computer, and then you have the operations person who's migrating the code from the developer's environment, the test environment, to the production environment, and you would run into issues where the code simply wasn't working. And there's a lot of reasons why that would happen. The actual developer environment would often be very different or would have different dependencies in it. So the hardware, the software, there may be additional applications that were installed on the operating system that simply hadn't been transferred over to the operations environment. And so what you would have is a disconnect between the developer environment and the operations environment, making it difficult to actually roll out code. So you'd run into a program where when you rolled out code, you'd have to have a rollback plan in case the code wouldn't work in production. And so each release became an event where everybody got very stressed about the actual event of releasing code because you didn't know whether it was going to work. So DevOps really looks to address and solve a lot of these problems. So the key word that you'll often hear with DevOps is continuous integration. And what that means is essentially that as a developer is working on their code, code. The code is constantly being tested against not just the actual code itself with unit testing, but the environment with which it's going to be released in. And the goal from a DevOps model is that the breakdown of communication that happens with Waterfall and Agile, where developers and operations teams aren't working in the same environment, is being removed. And you're able to provide a continuous and contiguous environment between the developer and the actual operating model. So the reality is, when the developer is working on their code, they're actually working in an environment that is identical to the production environment. And so when the actual operations person comes to actually do releases for the code, and you can see some teams are doing as many as 20 to even up to 50 releases to production environments every single day, you're able to guarantee that the actual code itself will work, and releases go from being a stressful event to a byproduct of good testing and good setup and structure for how you actually build out your solutions. So what we're seeing here, so the goal is that as a developer and as an operations person, that the code is working continuously in both environments. You have continuous integration and continuous delivery. So simply put, what we're able to do is we're able to eliminate the problem of the operation environment not being in sync with the development environment. And this is an improvement on Agile. And this is not to say that Waterfall or Agile are wrong as delivery models. What it is just a maturity of the ability to deliver solutions, and DevOps is just another rung in that maturity curve, using tools that are available to us now that 5-10 years ago simply weren't available. So the goal is for you as a team to move to a DevOps model where you can implement continuous releases on your software as long as you're using the tools that are available. And the good news is those tools are open source tools. So let's go through some of the benefits of why you'd want to go and use DevOps. So, essentially, what's in it for you? So over the next few slides, we're going to go through what is DevOps. We're going to go through the benefits of DevOps. So in the last few slides, you've actually seen what is DevOps and the benefits of DevOps along with the life cycle. But we're also going to start digging into the tools that you have that are useful for DevOps. And we're going to focus in on 7 tools that can provide an end-to-end infrastructure for delivering DevOps solutions. There are significantly more tools available on the market, but these are 7 of the most popular for each of their categories. So DevOps really is an essential collaboration between the development team and the operations team. These are teams that have in past been somewhat at conflict with each other, and what you have now is an opportunity where those teams can now work continuously with each other. The expectation with DevOps is that it will continue to mature. Indeed, you're actually even seeing some groups which are now called DevSecOps, where they're integrating security as part of the delivery between the development team and the operations team. The bottom line is a DevOps engineer is highly in demand. The demand for a DevOps engineer is literally going through the roof, with salaries going up exponentially around that. So let's dig into some of the benefits of DevOps. It's not just a new catchphrase, it's actually got significant value and how you can speed up delivery of your software. So the benefits of DevOps can really be broken up into a number of key areas. First of all, we have continuous delivery of software, which allows you to continuously release new features with the security and understanding that the software going out is of high quality. It allows the teams that are working on the software delivery within your organization to more effectively collaborate with each other. You're all talking from the same page and understanding of what needs to be delivered. The deployment process itself moves from being an event where there's a lot of stress and there's a lot of contingency plans to being a much easier deployment. The efficiency within the actual code that you're writing and the ability to scale up using the different tools that are available allows you to be able to bring in and scale up and reduce the teams you have running the software as needed. Errors can be fixed much earlier and more quickly and can be caught before anything gets pushed out to the production environment. And fundamentally, what we're looking for is improving the security of the actual releases. So the actual concept of security is center to all the work you're doing. And then finally, what really allows you to reduce the number of errors is that there is much less manual intervention. There is a greater reliance on scripted environments that you can actually test and validate for their security, reliability, and uptime efficiency. So let's talk a little bit about the life cycle of a DevOps. So the very first step that you'll take is to actually build out a build and test environment. And this is a continuous build and test environment. And this is managed with the first step of your source code. Once you move through that, then you're looking at continuous integration, which means that every time somebody checks in their code, they're validating that the code actually can run in the production environment. Once you've actually then passed the continuous integration and the testing that you have with your code, you're looking at continuous deployment. If the code works and is available to be released into the production environment, let's go ahead and release it. And once you actually have release code, then you want to be able to validate that your environment is working efficiently. You may release code that is a new feature within your application, and customers may then gravitate immediately to that new feature. If they do, you want to be able to ensure that the code is working, and more importantly, that the infrastructure is there to support. And then finally, you're looking at software released as a continuous event. And then you go back to the beginning. You start working on more code. You run it through your build environment and continuous integration, deployment, continuous monitoring, and keep that cycle moving. So let's dig into the tools that you as a DevOps engineer would need to learn. If we break down the environment that we have, all the way from source code management to software release, there are a number of key tools that you want to be able to use. So for instance, source code management, Git is an open source tool that you would want to use for managing your code. The continuous build and test environment will be managed with Maven and Selenium. Integration with the environments that you're working on is managed through Jenkins. The actual deployment to your production environments would be managed with products such as Ansible and Docker. And then the monitoring of your network would be used with tools like Nagios. The thing that you have to remember with all these tools is that they're open source tools. There is no licensing that you have to purchase. Some of the tools will have pro level licensing that you can choose to select. But to get started, all of these are open source tools you can actually start using for free right now.
So we'll start by downloading and installing Git on our system. We'll then have a look at the Git bash interface. We'll type in some basic Git commands. Next, we'll create a local repository. That is, we'll create a repository on our local machine. We'll then connect to a remote repository. And finally, we'll push the file onto GitHub. First things first, we need to download and install Git. So download Git for Windows. And I'll select the second link. So 2.19.1, which is the most latest version of Git, that's the one we want for Windows system. Choose your version. So mine is a 64-bit system and it's downloading. So this will take a while. So Git is finally downloaded. Now we need to install this on our system. Click here, run. So go to next. We don't have to change path. Just click on quick launch and on next. Next, again next, nothing to change here either. And install. So now Git is getting installed on our system. So we don't need to view the release notes, we just want to launch the Git bash. So let's just tick that and then click on finish. And your Git bash interface appears here. So we are on the master branch. The first thing we do is we'll check the version for our Git. So the command is git -- version. And as you can see, version 2.19.1 on our Windows system, which is exactly what we just downloaded. We'll now explore the help command. So let's just type git help config. So config is another command. And as I hit enter, the manual page for the second command opened up, which is config. So what help command does is that it provides the manual or the help page for the command just following it. So in case you have any doubts regarding how a command is used, what a command is used for, or the various syntax of the command, you can always use the help command. Now there's another syntax for using the help command itself, which is git config -- help. Enter. This does the exact same thing, as you can see. Now that we looked at the help command, let's begin by creating a local directory. So mkdir test. Now test is my new directory. I'll move into this directory. So cd test. Great. So now that we are inside our test directory, let's initialize this directory. So git init is the command for initializing the directory. And as you can see the path here, this is the local path where a directory is created. So I'll just show you the directory test, and it's completely empty. What we do now is we'll create a text file within this new directory that we created. So new text document, and I'll just name this demo. I'll open this and just put in some dummy content. So hello simply learn. Save this file and go back to your bash interface. Let's just check the status now. So git status, and as you can see, our file has appeared, it's visible, but nothing is committed yet. So this means that we have not made any change to our file through the git tool itself. So the next thing that we are going to do is we'll be adding demo to our current directory. The next command that we'll be applying is the commit command. And when you add certain files to the current directory, the commit command is applied on all the above directories. So git commit -m and a message that will appear once the file is committed. So as you can see, one file is changed and one insertion. I'll just clear the screen. Next thing we need to do is we need to link our Git to our GitHub account. So the command for doing that is git config global user.username. And this will be followed by our username. So let me just show you my GitHub account. So this is my GitHub profile and my username is simplylearn-github. So guys, before you begin this procedure, just make a GitHub account. Type in my username here, simplylearn-github, and enter. And there you go. Our Git is successfully linked with GitHub. Next thing we do is we'll just open our GitHub and we'll create a new repository. Give a repository name. So I'll name it test_demo and create repository. Great. So our repository is created. This is our remote repository. What we do next is just copy the link and then go back to your bash interface. Now we need to link our remote and our local repository. So git remote origin and then paste the HTTP link. And now that our local repository and our remote repository are linked, we can push our local file onto our remote repository. So the command for doing that is git push origin master, as we are on the master branch. And that's done. So now let's move back to GitHub. I'll just click on test demo. And as you can see here, our local file has been pushed to our remote repository. With that, we have successfully completed our demo.
So we're going to introduce the concept of version control that you will use within your DevOps environment. Then we'll talk about the different tools that are available in a distributed version control system. We'll highlight a product called Git, which is typically used for version control today. And you'll also go through what are the differences between Git and GitHub. You may have used GitHub in the past or other products like GitLab, and we'll explain what are the differences between Git and services such as GitHub and GitLab. We'll break out the architecture of what a Git process looks like. How do you go through and create forks and clones? How do you have collaborators being added into your projects? How do you go through the process of branching, merging, and rebasing your project? And what are the list of commands that are available to you in Git? Finally, I'll take you through a demo on how you can actually run Git yourself. And in this instance, use the software of Git against a public service such as GitHub. All right, let's talk a little bit about version control systems. So you may have already been using a version control system within your environment today. You may have used tools such as Microsoft's Team Foundation services, but essentially the use of a version control system allows people to be able to have files that are all stored in a single repository. So if you're working on developing a new program, such as a website or an application, you would store all of your version control software in a single repository. Now, what happens is that if somebody wants to make changes to the code, they would check out all of the code in the repository to make the changes. and then there would be an addendum added to that. So there would be the version 1 changes that you had, then the person would then later on check out that code, and then be a version 2 added to that code. And so you keep adding on versions of that code. The bottom line is that eventually you'll have people being able to use your code, and that your code will be stored in a centralized location. However, the challenge you run into is that it's very difficult for large groups to work simultaneously within a project. The benefits of a VCS system, a version control system, demonstrates that you're able to store multiple versions of a solution in a single repository. Now let's take a step at some of the challenges that you have with traditional version control systems and see how they can be addressed with distributed version control. So in a distributed version control environment, what we're looking at is being able to have the code shared across a team of developers. So if there are 2 or more people working on a software package, they need to be able to effectively share that code amongst themselves, so that they constantly are working on the latest piece of code. So a key part of a distributed version control system that's different to a traditional version control system is that all developers have the entire code on their local systems, and they try and keep it updated all the time. It is the role of the distributed VCS server to ensure that each client, and we have a developer here, and developer here, and developer here, and each of those are clients, have the latest version of the software, and then that each person can then share the software in a peer-to-peer like approach. So that as changes are being made into the server of changes to the code, then those changes are then being redistributed to all of the development team. The tool to be able to do an effective distributed VCS environment is Git. Now, you may remember that we actually covered Git in a previous video, and we'll reference that video for you. So we start off with our remote Git repository, and people are making updates to the copy of their code into a local environment. That local environment can be updated manually and then periodically pushed out to the Git repository. So you're always pushing out the latest code changes you made into the repository. And then from the repository, you're able to pull back the latest updates. And so your Git repository becomes the kind of the center of the universe for you. And then updates are able to be pushed up and pulled back from there. What this allows you to be able to accomplish is that each person will always have the latest version of the code. So what is Git? Git is a distributed version control tool used for source code management. So GitHub is the remote server for that source code management, and your development team can connect their Git client to that remote hub server. Git is used to track the changes of the source code and allows large teams to work simultaneously with each other. It supports a non-linear development because of thousands of parallel branches, and has the ability to handle large projects efficiently. So let's talk a little bit about Git versus GitHub. So Git is a software tool, whereas GitHub is a service, and I'll show you how those two look in a moment. You install the software tool for Git locally on your system, whereas GitHub, because it is a service, it's actually hosted on a website. Git is actually the software that's used to manage different versions of source code, whereas GitHub is used to have a copy of the local repository stored on the service, on the website itself. Git provides command line tools that allow you to interact with your files, whereas GitHub has a graphical interface that allows you to check in and check out files. So let me just show you the two tools here. So here I am at the Git website, and this is the website you would go to download the latest version of Git. And again, Git is a software package that you install on your computer that allows you to be able to do version control in a peer-to-peer environment. For that peer-to-peer environment to be successful, however, you need to be able to store your files in a server somewhere. And typically, a lot of companies will use a service such as GitHub as a way to be able to store your files. So Git
can communicate effectively with GitHub. There are actually many different companies that provide similar service to GitHub. GitLab is another popular service, but you also find that development tools such as Microsoft's Visual Studio are also incorporating Git commands into their tools. So the latest version of Visual Studio Team Services also provides this same ability. But GitHub, it has to be remembered, is a place where we actually store our files and can very easily create public shareable. It is a place where we can store our files and create public shareable projects. You can come to GitHub and you can do a search on projects. You can see at the moment I'm doing a lot of work on blockchain, but you can actually search on the many hundreds of projects here. In fact, I think there's something like over 100,000 projects being managed on GitHub at the moment. That number is probably actually much larger than that. And so if you are working on a project, I would certainly encourage you to start at GitHub to see if somebody's already maybe done a prototype that they're sharing, or they have an open source project that they want to share that's already available in GitHub. Certainly if you're doing anything with Azure, you'll find that there are 45,000 Azure projects currently being worked on. Interestingly enough, GitHub was recently acquired by Microsoft, and Microsoft is fully embracing open source technologies. So that's essentially the difference between Git and GitHub. One is a piece of software, and that's Git, and one is a service that supports the ability of using the software, and that's GitHub. So let's dig deeper into the actual Git architecture itself. So the working directory is the folder where you are currently working on your Git project. And we'll do a demo later on where you can actually see how we can actually simulate each of these steps. So you start off with your working directory where you store your files, and then you add your files to a staging area where you are getting ready to commit your files back to the main branch on your Git project. You want to put out all your changes to a local repository after you've made your changes, and these will commit those files and get them ready for synchronization with the service, and will then push your services out to the remote repository. An example of a remote repository would be GitHub. Later, when you want to update your code, before you write any more code, you would pull the latest changes from the remote repository so that your copy of your local software is always the latest version of the software that the rest of the team is working on. One of the things that you can do is, as you're working on new features within your project, you can create branches, you can merge your branches with the mainline code. You can do lots of really creative things that ensure that A, the code remains at very high quality, and B, that you're able to seamlessly add in new features without breaking the core code. So let's step through some of the concepts that we have available in Git. So let's talk about forking and cloning in Git. So both of these terms are quite old terms when it comes to development, but forking is certainly a term that goes way back, long before we had distributed CVS systems such as the ones that we're using with Git. To fork a piece of software is a particular open source project. You would take the project and create a copy of that project, but then you would then associate a new team and new people around that project. So it becomes a separate project in entirety. A clone, and this is important when it comes to working with Git, a clone is identical with the same teams and same structuring as the main project itself. So when you download the code, you're downloading an exact copy of that code with all the same security and access rights as the main code. And then you can then check that code back in, and potentially your code, because it is identical, could potentially become the mainline code in the future. Now, that typically doesn't happen. Your changes are the ones that merge into the main branch, but you do have that potential where your code could become the main code. With Git, you can also add collaborators that can work on the project, which is essential for projects particularly where you have large teams. This works really well when you have product teams where the teams themselves are self-empowered. You can do a concept what's called branching in Git. And so say, for instance, you are working on a new feature. That new feature and the main version of the project have to still work simultaneously. So what you can do is you can create a branch of your code so you can actually work on the new feature, whereas the rest of the team continue to work on the main branch of the project itself. And then later you can merge the two together. Pull from remote is the concept of being able to pull in services, software the team is working on from a remote server. And Git rebase is the concept of being able to take a project and re-establish a new start from the project. So you may be working on a project where there have been many branches and the team has been working for quite some time on different areas, and maybe you kind of losing control of what the true main branch is. You may choose to rebase your project. And what that means though is that anybody that's working on a separate branch will not be able to branch their code back into the mainline branch. So going through the process of a Git rebase essentially allows you to create a new start for where you're working on your project. So let's go through forks and clones. So you want to go through the process. So you want to go ahead and fork the code that you're working on. So let's use this scenario that one of your team wants to go ahead and add a new change to the project. The team member may say, yeah, go ahead and create a separate fork of the actual project. So what does that look like? So when you actually go ahead and create a fork of the repository, you actually go and you can take the version of the mainline branch, but then you take it completely offline into a local repository for you to be able to work from. And you can take the mainline code and you can then work on a local version of the code separate from the mainline branch. It's now a separate fork. Collaborators is the ability to have team members working on a project together. So if someone is working on a piece of code and they see some errors in the code that you've created, none of us are perfect at writing code. I know I've certainly made errors in my code. It's great to have other team members that have your back and can come in and check and see what they can do to improve the code. So to do that, you have to then add them as a collaborator. Now you would do that in GitHub. You can give them permission within GitHub itself. It's really easy to do, super visual interface that allows you to do the work quickly and easily. And depending on the type of permissions you want to give them, sometimes it can be very limited permissions. It may be just to be able to read the files. Sometimes it's being able to go in and make all the changes. You can go through all the different permission settings on GitHub to actually see what you can do. But you'll be able to make changes so that people can actually have access to your repository, and then you as a team can then start working together on the same code. Let's step through branching in Git. So suppose you're working on an application, but you want to add in a new feature. And this is very typical within a DevOps environment. So to do that, you can create a new branch and build a new feature on that branch. So here you have your main application on what's known as the master branch. And then you can then create a sub branch that runs in parallel, which has your feature. You can then develop your feature and then merge it back into the master branch at a later point in time. Now, the benefit you have here is that by default, we're all working on the master branch. So we always have the latest code. The circles that we have here on the screen show various different commits that have been made so that we can keep track of the master branch and then the branches that have come off which have the new features. And there can be many branches in Git. So Git keeps the new features you're working on in separate branches until you're ready to merge them back in with the main branch. So let's talk a little bit about that merge process. So you're starting with the master branch, which is the blue line here, and then here we have a separate parallel branch which has the new features. So if we're to look at this process, the base commit of feature B is the branch. F is what's going to merge back into the master branch. And it has to be said there can be so many divergent branches, but eventually you want to have everything merge back into the master branch. Let's step through Git rebase. So again, we have a similar situation where we have a branch that's being worked in parallel to the master branch, and we want to do a Git rebase. So we're at stage C, and what we've decided is that we want to reset the project so that everything from here on out along the master branch is the standard product. However, this means that any work that's been done in parallel as a separate branch will be adding in new features along this new rebased environment. Now, the benefit you have by going through the rebase process is that you're reducing the amount of storage space that's required for when you have so many branches. It's a great way to just reduce your total footprint for your entire project. So git rebase is the process of combining a sequence of commits to form a new base commit. And the primary reason for rebasing is to maintain a linear project history. When you rebase, you unplug a branch and replug it in on the tip of another branch. And usually you do that on the master branch, and that will then become the new master branch. The goal of rebasing is to take all the commits from a feature branch and put it together in a single master branch. And it makes the project itself much easier to manage. Let's talk a little bit about pull from remote. Suppose there are two developers working together on an application. The concept of having a remote repository allows the two developers will be actually then checking in their code into a remote repository that becomes a centralized location for them to be able to store their code. It enables them to stay updated on the recent changes to the repository because they'll be able to pull the latest changes from that remote repository so that they are ensuring that as developers, they're always working on the latest code. So you can pull any changes that you have made to your forked remote repository to your local repository. The command to be able to do that is written here, and we'll go through a demo of how to actually do that command in a little bit. Good news is if there are no changes, you'll get a notification saying that you're already up to date. And if there is a change, it will merge those changes to your local repository and you get a list of the changes that have been made remotely. So let's step through some of the commands that we have in Git. So git init initializes a local Git repository on your hard drive. Git add adds one or more files to your staging area. Git commit -m commit message is a commit changes the git command commits changes to head up. So the git command commits changes to your local staging area. Git status checks the status of your current repository and lists the files you have changed. Git log provides a list of all the commits made on your current branch. Git diff views the changes that you've made to the file. So you can actually have files next to each other and you can actually see the differences between the two files. Git push origin branch name, so the name of your branch command, will push the branch to the remote repository so that others can use it. And this is what you would do at the end of your project. Git config -global username will tell Git who you are by configuring the author name, and we'll go through that in a moment. Git config global user email will tell Git the author of by the email ID. Git clone creates a Git repository copy from a remote source. Git remote add origin server connects the local repository to the remote server and adds the server to be able to push to it. Git branch and then the branch name will create a new branch for you to create a new feature that you may be working on. Git checkout and then the branch name will allow you to switch from one branch to another branch. Git merge branch name will merge a branch into the active branch. So if you're working on a new feature, you're going to merge that into the main branch. A git rebase will reapply commits on top of another base tip. And git rebase will reapply commits on top of another base tip. And these are just some of the popular Git commands. There are some more, but you can certainly dig into those as you're working through using Git. So let's go ahead and run a demo using Git. So now we are going to do a demo using Git on our local machine and GitHub as the remote repository. For this to work, I'm going to be using a couple of tools. First, I'll have the deck open as we've been using up to this point. The second is I'm going to have my terminal window also available. And let me bring that over so you can actually see this. And the terminal window is actually running Git Bash as the software in the background, which you'll need to download and install. You can also run Git Bash locally on your Windows computer as well. And in addition, I'll also have the GitHub repository that we're using for Simply Learn already set up and ready to go. All right, so let's get started. So the first thing we want to do is create a local repository. So let's go ahead and do exactly that. So the local repository is going to reside in my development folder that I have on my local computer. And for me to be able to do that, I need to create a drive in that folder. So I'm going to go ahead and change the directory. So I'm actually going to be in that folder before I actually create and make the new folder. So I'm going to go ahead and change directory. And now I'm in the development directory. I'm going to go ahead and create a new folder. and that's gone ahead and created a new folder called Hello World. I'm going to move my cursor so that I'm actually in the Hello World folder. And now that I'm in the Hello World folder, I can now initialize this folder as a Git repository. So I'm going to use the Git command init to initialize, and that's going ahead and initialize that folder. So let's see what's happened. So here I have my Hello World folder that I've created, and you'll now see that we have a hidden folder in there which is called .git. And if we expand that, we can actually see all of the different subfolders that Git repository will create. So let's just move that over a little bit so that we can see the rest of the work. And now if we check on our folder here, we'll actually see this is users Matthew development hello world.git, and that matches up with hidden folder here. So we're going to go ahead and create a file called readme.txt in our folder. So here is our Hello World folder, and I'm going to go ahead and using my text editor, which happens to be Sublime, I'm going to create a file, and it's going to have in there the text Hello World, and I'm going to call this one readme.txt. If I go to my Hello World folder, you'll see that we have the readme.txt file actually in the folder. What's interesting is if I select the git status command, what it'll actually show me is that this file has not yet been added to the commits yet for this project. So even though the file is actually in the folder, it doesn't mean that it's actually part of the project. For us to do that, we actually have to go and select For us to actually commit the file, we have to go into our terminal window, and we can use the git status to actually read the files that we have there. So let's go ahead and use the git status command, and it's going to tell us that this file has not been committed. You can use this with any folder to see which files and subfolders haven't been committed. And what we can now do is we can go and actually add the readme file. So let's go ahead and we're just going to select git add. So the git command is add readme.txt. So that then adds that file into our main project, and we want to then commit those files into the main repository's history. And so to do that, we'll hit the git command commit, and we'll do a message in that commit, and this one will be first commit, and it has committed that project. What's interesting is we can now go back into readme file, and I can change this. So we can go hello git. Git is a very popular version control solution, and we'll save that. Now what we can do is we can actually go and see if we have made differences to the readme text. So to do that, we'll use the diff command for git. So we do git diff, and it gives us two releases. The first is what the original text was, which is hello world, and then what we have afterwards is what is now the new text in green, which has replaced the original text. So what we're going to do now is you want to go ahead and create an account on GitHub. We already have one. So what we're going to do is we're going to match the account from GitHub with our local account. So to do that, we're going to go ahead and select git config, and we're going to do dash, and it's going to be a global user name, and we're going to put in our username that we use for GitHub. In this instance, we're using the simply learn dash GitHub account name. And under the GitHub account, you can go ahead and create a new repository name. In this instance, we call the repository hello-world. And what we want to do is connect the local GitHub account with the remote hello world.git account. And we do that by using this command from get, which is our remote connection. And so let's go ahead and type that in. Open this up so we can see the whole thing. So we're going to type in get remote add origin https / github.com/simplylearn-github, and you have to get this typed in correctly when you're typing in the location hello-world.get. That creates the connection to your Hello World account. And now what we want to do is we want to push the files to the remote location using the git push command. Commit git push origin master. So we're going to go ahead and connect to our local remote GitHub. So I'm just going to bring up my terminal window again. And so let's select git remote add origin, and we'll connect to the remote location github.com/simplylearn-hello-world.get. Oh, we actually have already connected, so we're connected to that successfully. And now we're going to push the master, gish. So git push origin master, and everything is connected and successful. And if we go out to GitHub now, we can actually see that our file was updated just a few minutes ago. So what we can actually do now is we can go and fork a project from GitHub and clone it locally. So we're going to use the fork tool that's actually available on GitHub. Let me show you where that is located. And here is our branching tool. It's actually changed more recently with a new UI interface. And once complete, we'll be able to then pull a copy of that to our account using the fork's new HTTP URL address. So let's go ahead and do that. So we're going to go ahead and create a fork of our project. Now, to do that, you would normally go in, when you go into your project, you'll see that there are fork options in the top right-hand corner of the screen. Now, right now, I'm actually logged in with the default primary account for this project. So I can't actually fork the project as I'm working on the main branch. However, if I come in with a separate ID, and here I am, I have a different ID, and so I'm actually pretending I'm somebody else, I can actually come in and select the fork option and create a fork of this project. And this will take just a few seconds to actually create the fork. And there we are. We have gone ahead and created the fork. So you want to select clone or download with this. And so this is the, I select, that'll actually give me the web address. I can actually show you what that looks like. I'll open up my text editor. Oops, that's not correct. I guess that is correct. So I'm going to copy that. And I can fork the project locally and clone it locally. I can change the directory, so I can create a new directory that I'm going to put my files in and then post in that content into that folder. So I can now actually have multiple versions of the same code running on my computer. I can then go into the forked content and use the patchwork command to actually, so I can create a copy of that code that we've just created, and we call it, that's a clone, and we can create a new folder that we're actually putting the work in, and we could, for whatever reason we want to, we could call this folder patchwork, and that would be maybe a new feature, and then we can then paste in the URL of the new directory that has the forked work in it. And now at this point, we've now pulled in and created a clone of the original content. And so this allows us to go ahead and fork out all of the work for our project onto our computer. So we can then develop our work separately. So now what we can actually do is we can actually create a branch of the fork that we've actually pulled in onto our computer. So we can actually then create our own code that runs in that separate branch. And so we want to check out the branch and then push the origin branch down to our computer. This will give us the opportunity to then add our collaborators. So we can actually then go over to GitHub and we can actually come in and add in our collaborators. And we will do that under settings and select collaborators. And here we can actually see we have different collaborators that have been added into the project. And you can actually then request people to be added via their GitHub name or by email address or by their full name. One of the things that you want to be able to do is ensure that you're always keeping the code that you're working on fully up to date by pulling in all the changes from your collaborators. You can create a new branch and then make changes and merge it into the master branch. To do that, you would create a folder, and then that folder in this instance would be called test. We would then move our cursor into the folder called test and then initialize that folder. So let's go ahead and do that. So let's create a new folder, and we're going to first of all change our root folder. We're going to go to development, and we're going to create a new folder. We call it test, and we're going to move into the test folder, and we will initialize that folder. And we're going to move some files into that test folder. Call this one test1, and then we're going to do file save as, and this one's going to be test2, and now we're going to commit those files. Git add, and then we'll use the dot to pull in all files, and then git commit -m files committed. Make sure I'm in the right folder here. I don't think I was. And now that I'm in the correct folder, let's go ahead and git commit. And it's gone ahead and added those files. And so we can see the two files that were created have been added into the master. And we can now go ahead and create a new branch. You can call this one git branch test _ branch. And let's go ahead and create a third file to go into that folder. This is file 3. We'll do file save as. We'll call this one test3.txt. And we'll go ahead and add that file. And do git add test3.txt. And we're going to move from the master branch to the test branch. Git check out test underscore branch, and it switched to the test branch, and we'll be able to list out all of the files that are in that branch now. And we want to go through and merge the files into one area. So let's go ahead and we'll do git merge test underscore branch, and it's, well, we've already updated everything, so that's good. So otherwise it would tell us what we would be merging. And now all the files are merged successfully into the master branch. There we go, all merged together. Fantastic. And so what we're going to do now is move from master branch to test branch. So git checkout test underscore branch, and we can modify the files, the test3 file that we took out, and pull that file up. And we can now modified. And we can then commit that file back in. And we've actually been able to then commit the file with one changes, and we see it's the text-free change that was made. And we can now go through the process of checking the file back in, switching back to the master branch, and ensuring that everything is in sync correctly. We may at one point want to rebase all of the work. It's kind of a hard thing you want to do, but it will allow you to allow for managing for changes in the future. So let's switch to it back to our test branch, which I think we're actually on. We're going to create 2 more files. Let's go to our folder here and let's go copy those. And that's created. We'll rename those tests 4 and 5. And so we now have additional files. And we're going to add those into our branch that we're working on. So we're going to go in and select git add -a, and we're going to commit those files. Git commit -a -m, adding 2 new files, and it's added in the 2 new files. So we have all of our files now. We can actually list them out, and we have all the files that are in the branch. And we'll switch then to our master branch. We want to rebase the master, so we do git rebase master, and that will then give us the command that everything is now completely up to date. We can go git checkout master to switch to the master account. This will allow us to then continue through and rebase the test branch and then list all the files so they're all in the same area. So let's go git rebase test underscore branch, and now we can list, and there we have all of our files listed in correctly.
Now we will be talking about that how exactly we can make use of Maven here in performing various kind of operations, whether it's a build, compilation, various kind of stuff there. So let's talk about it, why exactly we use Maven here. Now Maven is something which is a kind of a build tool which is there for most of the Java-based projects here. So this tool also helps us in building up the source code by downloading some couple of dependencies. These dependencies are something which is being configured by the developers, which a developer feels that the project is dependent on, and he requires those dependencies to be downloaded. So this tool is specifically used to build and manage any kind of a Java-based project, whatever the complexity of the topic or the project is there. So this tool will be able to handle that particular requirement or that project. So it simplifies the day-to-day work of a Java developer and helps them in their projects for performing daily to daily activities. Right now, Maven also helps us in getting the specific jar files for each and every project. So if you are going, you can pretty much make a jar file, var file, or ER file, any kind of a package mechanism you can follow for your Maven there. So to download the dependencies, we don't have to actually go to the official website of each and every software. You can easily get it, the dependencies of each and every third-party binaries on the mvnrepository.com. This is a website which is present, on which if you visit, you will be able to download the dependencies which is required by your project or by your specific project over here. So it totally depends on how exactly you want to download and you want to get together a specific repository over here. So mvnrepository.com is the one. If you visit, you will be able to download and go through all the jar files, dependent jar files as in dependencies which you require for your current project. Right, so now what exactly is a Maven all about? So let's see on that part. So Maven is a popular open source build tool which is developed by the Apache group, and the primary ownership of this tool is to build, publish and deploy several projects at once. Maven is written in Java, and it can be used to build projects written in C#, Scala, Ruby, etc. So apart from Java, these are the different programming languages or the tools which is supported by the Maven here for performing the build activity. So the tool is used for build and management of any kind of a Java-based project. It simplifies the day-to-day work of a Java developer and helps them to automate most of the compilation or build perspective tasks on the projects. Right. Now Maven is a kind of a BOM-based project, so it also known as a project object model, and it focuses on simplification and standardization of the building process. In the process, it takes care of all the followings here: builds, dependencies, reports, distribution, releases, mailing list. So all these things are being taken care as in this particular process here, and ultimately it's an ability inside the Maven that how the overall build process needs to be automated and standardized here. So all these particular mechanisms can be followed as such over here, so that we can have a good standards and the simplifications implemented as such here. Now in this one, we are going to talk about that how we can work on Maven installation on Windows and Ubuntu platform here. So first of all, we'll do it on the Windows platform here, and we'll see that how the installation really works. So for this one, I will be doing the installation into my local system. Now before even going for Maven, Maven is a kind of a build tool which is available there, primarily for performing any kind of build automation for the Java-based projects. Now since it's used for Java, we also require the JDK installation onto our system. So for that, both of the installations we will be covering over here, and we'll see that how the installation really works as such over here. Right, so before even going for Maven, we have to install the JDK onto our Windows machine so that we can proceed with Maven, because Maven requires the JDK installations to be there. Now there are two ways of JDK installation. Either you go for the exe file, or you extract the binaries of JDK to a directory and then set up the java_home path for that. But if you are using the executable, that will perform the path configurations for you also. So in that case, you don't have to reconfigure it again and again. So that's what we are going to see here. So first of all, we will try to do the installation of JDK. So for that, we'll go to the website of JDK, and then we have to click on this one to access the Maven installations part here. So that's what we are going to do. So let's proceed, and let's open the Chrome and try to go through these two URLs so that we can do the installations one by one. So here I have to just search for JDK 8 download. So it will show me the URL for oracle.com. So here you will get the JDK for the different platforms for different operating systems. Now here what you can see here that you have the configurations in which you have the JDK installation. So we have to So here I'll go for the Windows 64 version, because that is something I will be using to do the installation. So this is the complete executable link. So here you can download. So we are downloading the SDK U251. So just search for Windows 64. Yeah, this is the one. So let me click on this one. Let me quickly log into the web page. So once the login is done, you will be able to see that it's trying to download the exe file. So that was for the JDK, for the Java. Now for the Maven, I am going to go for the Maven download over here. So in this one, the Maven repo link is there. maven.apache.org is the link for this one. Now here we have the different options. You can see here that the binary zip archive is there, then source zip archive is there. So depending on the installation which you want to perform, you should be able to download that file and it works there. So let's first install the JDK portion and then we'll go with this one. So we'll click on this one also anyways, because it's something we have to anyways do it. So we'll click on this so that this Maven is also getting started downloading over here. So once both of them are downloaded, we will proceed further with the setup. So let's wait for another 1 minute to do this one. So the Apache Maven is kind of downloaded over here. So we wait for the JDK download also over here. So next 5-10 seconds only left out. So first JDK will be there and then Maven installation configurations will be there. So for Maven, we just have to extract into a directory and give the MVN home path into the properties, into the variables, so that it can pick it up over there. Okay, so we have to extract the zip file for Maven, give the path, and then we will check with the Maven command whether it's working fine or not. So let's try to install the executable. So we'll open the directory where the executables are there. So first of all, we'll install the JDK. So we'll double click the installer for JDK. It's of around 200 MB. So the complete JDK will be installed. So we have to just go for next. Now when you go with the installer, so usually the Java home paths and all that stuff is already configured. So you don't really have to change the passwords or Java home, any kind of variable you have to put it up. All those things will be automatically cleaned up. So it's running the installation. Close. So then we have to extract the Maven. So we have to extract this directory because here the Maven complete executables and libraries are there. So we just have to extract it and place into a directory so that we can further on use it and access the path. So once the access is done, yep, so this is done there. So I can rename it to like Maven. So I can rename it like to as Maven, and I can cut it down and put it into the C drive here. Now this is the Maven home path which is going to be there, right? So all I have to do is that I have to close this one and this one and this one and this. So what we have to do is that we have to really go to the system properties so that we can extract it. So I'm going to open the system properties over here. Properties. Now here the advanced system settings. Now in this one we will be setting up the paths. So environment variable will go. Now here if you scroll down, you will see all the different paths which is available there as such over here. Now if we want to see that if the Java is fine or we require for JDK also, so all we have to do is that we have to open the CMD prompt. Window R we are providing. So using the window R, I'm opening the run window where I can say like CMD. Now in this CMD, I'm going to say like Java -version. So Java is there, so which means that we don't have any problem as such. Now I'll just go here and set up a new one called MVN_home. So here the same path. So you can browse for directory also, but I am using the MVN home over here in this one. Now I have just added that, and in the path variable in the last we have to actually add the bin directory also, so that whenever we run the mvn command, so that should also be resolved. So mvn_home is not the only variable which you will be configuring. In fact, you will be configuring the path variable also, that you can go ahead and put up a new directory entry for the cmd here. So cmd till the cmd directory, you will go there, and whatever the executable is there, you should be able to resolve that. So for that, again you have to open the window R, cmd prompt, Java-version, and then you can run mvn-version here. when you run the mvn-version, it will let you know that which particular Java runtime you are using, 1.8.0_251. That's the same one which we have configured. And it also let us know that where exactly the executable is there, and we can now proceed further with the execution of the Maven build. So you just have to check out your source code or go to the directory where source code is there, and you can run the mvn clean install. So that will ultimately go for the build process. So this is the way that how we can do the installation of Maven on the Windows platform. Now since this is done, now we will go ahead with the second installation, where we are going to do the installation of Maven and JDK onto the Ubuntu machine. So for that we will log into the particular cloud lab of Simplilearn LMS. So let's log into the LMS here. So now we are going to do the installation of JDK and Maven on the Ubuntu virtual machine here. So for that we will log into the LMS. So let's log into that. So this is the LMS over here. Here I have already started the lab here. So all I have to do is that I have to just click on this link here. So it will open the lab into a new tab. It's a GUI mode of Ubuntu server, so which we will be using to configure it. So here first of all I can open the Chrome browser also. So let me open the browser here so that I can download the Maven executables as such over here. So JDK we can do it using the package installation. So using the apt executable we will be doing the installation. So I have to just open the terminal here. So once the terminal is opened, you have to log in through the root ID. Now why we require root ID? So that we should be able to do the package installations and other configurations. So that requires root access. Now once that is done, you have to run the particular app update command. Next you have to install the installer. So the Oracle installer we have to install. Now once the setup is done, so let's install the latest package over here for Oracle-Java 14-installation. So this will install the JDK 14 over here. So for that configurations. Now at the same time we'll go for Maven download also. So here we'll go for download Maven. So this is the tar file for executable. So I'm going to copy this URL here, and over here we'll say yes. So now the Java should be configured and should be set up over here in this one. So what we really need to do is that we need to run the Java command to see that if the installation is done properly or not. So let's open the terminal again, another terminal, so that I can perform the steps related to Maven. So I have got the URL, so I'm going to the OPT directory, which is always an optional directory where we can do the setup and all those configurations. So I'm going to run the wget command and then the URL which I have downloaded. So this should download the tar file over here of Maven. Now once that is done, so I have to extract it. So tar-xvzf and the tar file name. This is a tar-gunzip file, so I have to use tar-xvzf parameter over here to extract it. Now what exactly I have got? I have got the Apache Maven directory over here, so I'm going to rename it. In order to rename it, what we need to do, we need to actually go for the particular move command. So move whatever the existing folder you have, and then I'm going to rename it with the Maven directory. Now once that is done, I'm going to the Maven directory, and this is the path or Maven_home path which is available as such over here in this one. So here all the bin directories, executables, all this stuff is there. So now I can use it like mvn_home and the same configuration just like we did in the Windows. So here also the same process we have to follow. So Java version should be let me know that which version is deployed. So 14.01 version is deployed over here. So for Java I don't have to set up the path again here because I'm using for the installer, so I don't have to set up the path, right? So for Maven, now what exactly I have to do, I have to go to the etc profile D. Now here I'm going to put up a particular file. Now here you can see that we have the JDK file here, which means that the path variables and everything is configured as such over here. So you can see that Java_home, path, all these variables are copied here. So I'm going to also create a same file similar to this one here, but in this case what I'm going to use it that I'm going to remove some of the values. So I'm going to have some of the parameters added. So in order to do it effectively, I can do the echo command so that I can copy the things from here, and I can simply put it up into the file here. So I'm going to have the path variable added up over here. Now why I'm putting up the path? Because it's the same configuration which we did over there also. So opt/maven/bin. So all the bin directories should be added to the specific path variable. So I'm just trying to create a file called maven.sh. Just like a jdk.sh over here, I'm also creating similar kind of file over here called maven.sh. Now I'm not going in the vi mode or other editors, because I just want to make you understand that how I'm copying it, the content. I'm taking the jdk.sh as a reference and putting up the details over here in this one. And then I'm going to export mvn_home over here, which is related to like opt/maven. So this is what we are going to put up over here, and then maven. In the end, maven, this is the file which you should be having. Now why we are using it? Because of the fact that it's being used, or it will be utilized in such a way that you can perform the changes or whatever configurations you want to perform. This will help you to set up the certain paths like path and mvn home, so that you can run these scripts as such over here. So I'm going to give the executable permissions to this one, and that's it. So now what exactly I have to do is that I have to do the source here, profile.dmaven. Once that is done, I will be able to run the mvn-version over here, and the JDK part is already open, so it's going to refer to that part. So this is the way that how we configure the Maven and the JDK specifically on the Ubuntu virtual machine. So pretty much that's it for this demo. In this demo, we primarily talked about that how we can do the installation of JDK and Maven on Windows, and how we can do the similar task on the Maven on the Ubuntu virtual machine also here. Hello everyone, welcome to this demo. In this demo, we are going to talk about it how exactly we can do the installation of Maven on the Mac operating system. So here we are going to talk about it how we can do for a specific setup, where we can do for the installation of Maven in a Mac operating system. So let's see. So there are two ways of doing the installation here. First is through the brew executable on the Mac. Now this brew utility on Mac is just like apt or yum utility, which is present in most of the environments or most of the platforms here. But here we are using this brew to do the installation of Maven on the Mac operating system. And again, the next one is just a particular mechanism where you should be able to have the setup, like you can download the binaries from the Apache website, and then you can export the m2_home and the path variable so that you can start using the Maven executable. So we'll talk about these things, and we'll see that how exactly we can go for this setup. So let's log in to a particular machine or Mac operating system, so where we will be able to do all this activity. So this is the Mac system which we have here. Now in this one, what we are going to do is that we are going to open the terminal. So we are going to open a terminal here. So this is my terminal. So usually in Mac, you don't require any other mechanism. So the inbuilt terminal is more than sufficient for doing this stuff, because it's similar to a Linux based platform here. So I'm going to run the command here. So first of all, I'll just double check that if my brew executable is working fine. So I'll just run the brew help command to see that if my brew is working fine as such over here in this one. Now I have the command called brew install. So that is a command which we need to use. Now in this one, we have to actually give the specific package which we want to install. So we will say like brew install Maven. So it will download the specific executables on the system. From the website, it will download the Maven executables. So it will take some time, but ultimately it's trying to download it and the particular tar file. So you can see here that it's downloading 3.6.3 tar file over here. So I can see that the installation is done. So the 3.6.3 version should be installed over here. So when I do like Maven mvn version over here, so you can see that the 3.6.3 version is deployed as such over here. Now this is something which is done with a purely command over here called brew, which really helps us to do any kind of package installations. Not only Maven, other packages also can be installed pretty much with the help of this executable. Now, in order to see the manual stuff, what we really need to do is that we need to actually clean this specific installation, so that I will be able to show you the manual installation also over here. So what I'm going to do is that I'm going to run the command called brew uninstall maven, so that the maven should be removed from your system. So we are just trying to remove the maven from here, and you can see that the maven executable is not working as such over here, so which means that the maven is uninstalled in this case. But why I have uninstalled here? So that I should be able to go ahead and download some custom maven over here in this one. So I have opened the browser here, so I'll go for the maven executable. So we'll go for maven download, so that we should be able to download a specific the executable here. So I'm going for this directory. So here 3.6.3 version same is available here. So I'm going to download the bin.tar.gz, which was the file we have. So this is also a kind of a Linux platform, right? So that's the reason why here the tar file should work perfectly fine. So here I'm going to the opt directory, where we can have all the optionals related packages. So if it is not there, so I can create a directory called /opt. So I can log in with root. So if you don't have the root access, so you can go for the applications. In the applications, you can actually create a directory called maven. So here I can go for maven. Yeah. So here we will be downloading the var file here. So the tar.gunzip file we are downloading over here. So I'll give the path here. So once the var file or wget command I am using to do the installation, but sometimes the wget is not available. So I can go for the brew install wget also. If that package is available on brew, the installation will be done. So we'll try to do the installation using wget, so that we will be able to get a tar file generated or downloaded. There are other ways also. You can download it from the browser also. Yeah, you can go to the browser, and here you can actually click and download it, and then you can transfer it locally to this specific directory also. So both the possibilities are there, but I'm just trying to download the wget command, so that it will be easy for me to do the setup and to do the download over here. So I'm going to run the same command again. So it will download the tar file. So this is the tar file which is available over here. So I'm going to extract it over here. So once the extraction is done, so I'm going to rename it like to Apache Maven, so that I should not have any kind of versioning or these kind of parameters over here. And the Apache dot Maven hyphen this tar file I'm trying to remove as such over here. So this is what I have got as an end result over here. Now this is the current directory in which I have these applications and these setups going forward over here. So if I run the mvn hyphen version command, so that will not be giving me any kind of output over here, because still I have extracted the tar file, but that is not, the activity is not complete. I have to exactly set up some environment variables, so that I should be able to run this mvn command. So what I really need to do over here is that we have to export certain variables. Application slash maven Apache Maven. So this is the home directory which I'm trying to configure over here. And then next thing is that path variable. So I'm going to have, we are going to coordinate the path variable with the folder. So I'm going to have the folder structure here. So the bin directory we have to provide. So I'm going to copy here and paste, and then I'm concatenate it with the bin here. So now my environment variables are established. So my mvn hyphen version command, as you can see here, is that it's being picked up over here, but it's saying that the particular Java runtime is not available. So I can go for Java brew install Java. So that should be enough there to install a Java package there. So you can see that it says that it's already installed, so and up to date. So that's the reason why it's not able to do the installation. So I'm going to reinstall open JDK. Because what happens that when we do the installation, some environment variables related to Java should be formatted or should be extracted over here, right? So as you can see that here it's saying that if you want to really use the executable of Java, you have to concatenate the path like this. So let's run that, and then we can see that the particular executable of Java will also be find out over here. So Java -version showing that yes, it's available there. And now my command should be able to show me that yes, it's working fine. The JDK was already installed, but the problem with that is that since it's installed into a particular location, so you have to actually override your path value so that you should be able to see in that directory and find out the Java executable. So that I have got by doing the deinstallation. I got the command over there in the output saying that this is the installation which is done, and now you just have to extract, or you have to just put that path directory into the specified path variable, and that's how you got the Maven and Java both command lines working over here. So this is how you will be doing the Maven installations all together, how the overall installation of Maven and the JDK really works on Mac operating system. Now what exactly is a Maven repository all about? So Maven repository is something which is a kind of a directory, or it's kind of a location where we have all the jar files packaged all together in a single location. So depending on the software which you want to download, the dependent jar files can be downloaded from there. So the metadata refers to the POM files relevant to each project here. This metadata is what allows Maven to download the dependencies. Now there are three types of repositories from where we can download the dependencies. The first one is the local repository, second one is the remote repository, and the third one is the central repository. So these are the primary three types of repositories which is available there for a specific Maven over here. So whatever repository you want to follow, you want to access, you can pretty much access it and you can go with that. Right now, the local repository will be primarily present onto your PC. That's the way that how it's present there. And the particular remote repository is something which you can store on any remote machine or remote server. And the central repository is something which you can have it onto the internet. So usually the central repositories is something in which we can actually host our different kind of dependencies and the jar files over there. So local repository on the machine of the developer where the project material is saved. So all the particular dependencies jar file will be available on your local machine. Remote machine is the location where you can actually store all your particular dependencies, from where you can download these dependencies whenever you require it. So this repositories work similar to the central repository. Whenever anything is needed from the remote repository, it's first downloaded into your local repository, and then dependencies are cached locally, from where it will be referenced in the next, or whenever we want to refer that, we will be able to do that particular reference easily on that part. So this is the way that how the three particular repositories or Maven repositories really helps us for performing various kind of automations as such here. Right now, what are the basic concepts of Maven here? So some of the couple of basic concepts which is present in Maven is, like, for the first time we have the project object model. So project POM refers to the XML file which has all the information regarding the project, how this particular project should be built up, how the different build process should be automated there. It also has a description of the project, details regarding the versioning. Versioning information is also stored as such in this XML file, in this particular POM reference file as such over here. The XML file is which is there in the project home directory. So Maven is something which search for the POM file in the current directory. If it's able to find that particular POM file, so it will execute or it will proceed with the build step. Otherwise it will halt there itself. So this POM file is very important because it will act as a kind of a build script, and primarily the Maven tool will be able to process each and everything which is configured as such in this specific XML file there, and according to that only it will function or it will proceed further. Right Now, second thing is the dependencies and repositories. So dependencies usually refers to the Java files, so the Java libraries which we need into our particular project. So while working on the project, we may be having the dependency on couple of dependencies. So these dependencies we have to actually download, or we have to actually refer. And once these particular information or these details are referred, so what will happen that we need to download these specific dependencies from the particular Maven repositories. So if the dependencies are not present in your local repository, then Maven will try to download it from the central repository and cache it into your local repository. But first of all, it will look on into the local repository, and if it is not present in local, then only it will go to the remote or the central repository. Then we have build life cycles and phase and goals there. So build life cycles consists of the sequence of build phases, and each build phase consists of sequence of goals here. Now each goal is responsible for performing a specific task. When a phase is running all the goals related to that phase, and its plugins are also used to performing the compilation, preparing the artifacts, downloading the dependencies, all different things being done by the plugins here. Then we have the build profiles. So build profiles refers to a set of configuration values. Now generally we have the generic build process for all the environments or all the particular code base there, but sometimes we do have some kind of a differences there. So that is where we can go for the profiles, because a specific profile can have its own configuration, and whatever it's required for the build process, we can have different configurations stored inside the Maven build script here. Then different build profiles are added to the POM files, and which enables the different build as such here. So depending on these profiles, we can actually decide that how we need to proceed with the build process and how the different kind of build automations needs to be performed here. Then a build profile helps in customizing the build for the different environments, so that also we can perform as such while performing or while working on the different components and the different management here. So a build profile is something which you can configure, you can utilize, and depending on that build profile, we will be deciding whether to proceed further or how to decide on that particular factor. So these are something which we need to take care, or we need to work according to which we can decide that how the specific configurations and specific automation needs to be performed here. Now usually when we go for the Maven there, so we have to use some couple of Maven plugins. Now the goal of using these specific plugins is to automate some of the basic stuff like compilation, creating the var file, creating the jar file. So when we are using the plugins, we don't have to configure the steps or write the steps that how these specific plugins should be installed or should be referenced. It's ultimately the internal configurations which we are looking forward or which we are using while working on these specific plugins. So you can download some couple of plugins using which we will be able to decide that how a specific goals needs to be achieved here. So Maven has its own standard plugins that can be utilized. So if want to go for a custom one, so you can do that, but pretty much you can go for the default one, and you can pretty much have some specific goals executed with the help of these build plugins. Now next thing is the Maven architecture. So in Maven, what happens that let's talk about the basic architecture of Maven here. So the Maven executable, when it's deployed, so it usually reads the pom.xml file, which is the build script here. Now once the specific pom.xml file is being read out, so it will process the components. It will download, or it will process the dependencies, plugins, life cycles, phases and goals, and even the build profiles. And if any kind of interaction is required, so it will try to connect to the central repository or a remote repository, and according to that it will provide the information and provide the details as such. So Maven repository is something which is very important, because it's ultimately trying to connect to the Maven repository and try to achieve the various kind of automation here. So it's very important because ultimately it's trying to help us to go for the complete end-to-end build automation when we'll go for a specific POM based build automation. So Maven executable will read the pom.xml file, then download the dependencies defined into the pom.xml file, and that dependencies are cached locally from the remote or the central repository. Now then create and generate a remote report according to the requirement and execute the life cycles, phases, goals, plugins, etc. So it will process the pom.xml file there, and whatever the plugins and goals or the life cycles which is configured there, step by step each of them will be executed into a sequence here. Now let's talk about the overall build lifecycle of the Maven here. So what happens that the Maven build lifecycle is something which is a kind of a collection of different steps there, and this is something which is followed to perform a build automation for a specific project. So that there are pretty much 3 steps which is being done. So first one is the default. So it handles the project deployment there. Second, handles the project cleaning, which is a clean there, and then we have site. So it handles the creation of the project sites documentation there. So these are the 3 built-in particular life cycles which is available there at the Maven level, which you can utilize to perform a various kind of particular steps execution for your project. Right, so the build cycle has the different build phases or stages there, because when we are performing a build, a variety of things needs to be performed over here. So the first one is the compile, then test compile is there. So compilation is there for the source file, and test compile is there for the test cases. Test will execute the test cases, package will package the bundle, then we have the integration test to run the integration test cases, then we have the verify, then install goal is there, and the last one is the deploy, which is there to deploy the artifacts to the artifact tree. So all these things are the different phases and the stages which is being followed as per a specific build here. So during these builds, these are the different phases and the stages which we normally follow for performing the build automation. Now what is the exactly advantage of a specific Maven here? So that is something which we need to talk about, that how the particular automation needs to be done, or how we can actually go for the configurations where we feel that yes, we want to perform or we want to take certain benefits out of the implementation of Maven here. So for that, what happens that we have to see that the various kind of benefits. The first one is that Apache Maven helps manage all the processes there, such as building, documentation, releasing, and distribution in project management here. So the tool simplifies the process of project building. It increases the performance of the project and the building process altogether. And the task of downloading jar files and other dependencies is also done automatically. We don't have to indulge in any kind of download part as such manually over here. Right, and Maven provides easy access to all the required information. So Maven makes it easy for a specific developer to build a project in the different environments. So we don't have to worry about the environment, we don't have to worry about the infrastructure, nothing is required. Everything is available there inside this package, and depending on the particular, you can write the source code on one machine and you can pretty much do the build on another machine. And this is the reason how the build automation really happens on the first place, because the developer is writing the source code in one location and the same code is deployed onto the particular or built onto this Jenkins or any kind of build tool there. Right, in Maven you can easily add new dependencies, so you must write the particular dependencies in the POM file. So if you feel that you want to download some particular dependencies, so all you have to do is that you have to put that dependency into the specific pom.xml file there, and depending on that, the execution will be really performed and executed as such here. Right, so let's talk about the demo now. So let's see that how exactly we can go for this demo and we can perform the various kind of automations. So this is the virtual machine which we have here, on which the Maven is already installed. So we can run like mvn. So Maven will be available as in 3.6.3 here. Now I'm going to run a particular command called mvn archetype generate here. Let me create a directory here, a temp directory, and to perform this activity over there. So mvn archetype generate. Now once we run that, so what will happen, that it will download some of the binaries there, because ultimately what we are trying to do is that we are trying to generate a new project, like a Maven project. So a couple of particular plugins will be downloaded by the Maven executable so that it can achieve that particular execution. So we just have to wait for downloading all these values. Now here it's trying to give us a particular attributes, like it's asking the different attributes over here. So what exactly we want to configure. So if you want to configure, you can provide that details, otherwise you can perform or whatever the setup you want to perform. Now here it's asking for the version, so which kind of version we want to follow. So I'm going to follow like 5 here, so I'll press 5. Then a group ID which is there, so it's basically a kind of a group mechanism, so I can say like com dot simply learn. So that's the value which I'm providing here. Artifact ID, I can make it like a sample project or something like that. I can do, so that will be the artifact ID which is there. So version I am keeping the same only. So and yeah, so package same here. So I just want to create, so I'll just provide the value called yes and enter. So with this, what will happen, that a sample project will be created here, right? So whatever the artifact ID you provided, so according to that, the project is created in this directory. So you have to go into this directory and see that what exactly the files are created there. So you have the pom.xml file. Now this pom.xml file, when I open, so you can see here that there are some attributes, like you can have the values related to what version or group ID you want to follow. So this is the group ID, this is the artifact ID. So this is jar file. By default you can change it according to your requirement, and this is the version, and if you feel that you want to do the changes to the name, that also you can perform here. So by default the JUnit dependency is added, but if you want to keep on adding your own custom dependencies, you will be able to do that. Now in this case, if you run like mvn clean install, so it will be considered as a particular Maven project. A pom.xml file is already there present in the local directory. So according to that, the execution of the steps will be performed, and according to that, you will be able to get some desired values here. So ultimately in the target directory, you will be able to see that some couple of jar file or a specific jar file is generated here. So you can see that in the target directory, this jar file or this artifact is generated here. So this is a way that how we can actually go for a generic one, like a new particular project, and later on you can, depending